Hey everyone, welcome back. All right, we are continuing with our linear functions unit, and today we're going to be looking at word problems. So goal for today is pretty much everything word problems. So all the things we've done so far, writing linear equations in slope-intercept form, where we're given the slope, we're given the intercept, writing the equation of a line when we're given two different points, writing the equation of a line when we're given 1 point and the slope. So there's a lot of different things that are going to pop up in word problems that we're going to have to try and convert back into equations or functions again. Essential question for today is, how do I find the slope and the y-intercept when I'm given a linear equation word problem? Let's go. All right, so what we got here. This is an example of a question that we'll see in Khan Academy, and it might pop up in a unit test as well. So Sean tried to drink a slushie as fast as he could. He drank the slushie at a constant rate, so this tells us it's a linear equation. And there was originally 275 milliliters of slushie in the cup. After 13 seconds, 210 milliliters of slushie remained. So we're thinking about like a graph, and you had started full at 275, and after 13 seconds, it was down to 210. This is at 13. Question, how fast did Sean drink? This is our slope. So this is our rate of change, milliliters per second. So there is a rate of something changing versus another. So milliliters being the y value, seconds being the x. So how is the milliliters remaining in the cup changing per second of time? And the second part, how long did it take Sean to drink all of the slushie? So things we need to identify the solution. We're talking about y values, so that would be the milliliters in the cup. So that's the output of the function. The input is the time, so that's our independent variable or our domain. Constant value, that will be the starting amount. So there's 275 milliliters starting in the cup, and then the rate of change we need to figure out. So then what we do is we move forward and say, okay, how do we solve this? So we've got 2 points, 0, 275. So at 0 seconds, there's 275 milliliters of slushie in the cup. And we've got one at 13 to 10. So at 13 seconds, there's 210 milliliters of slushie in the cup. So if you do slope formula, now you don't really need to think about slope formula as much because we do have an intercept, but let's just do it anyway. So we got x1, y1, x2, y2. Slope formula, y2 minus y1 over x2 minus x1. So subbing in my values, that would be 210 minus 275 over 13 minus 0, which would be negative, negative 65 over 13, which is negative 5. So we got negative 5 milliliters per second, which makes sense. The slushie amount is going down. So minus 5. So how fast does Sean drink? He's drinking at 5 milliliters per second, but the amount in the cup is going down by minus 5. So if you have 5 in here, you're doing fine. How long did it take Sean to drink all of the slushie? So if we think of this as an equation, y equals mx plus b. So m is the slope, b is the y-intercept. This would be y equals minus 5x plus 275. So starting amount 275, going down by 5 every second. The output, so the amount of slushie left would be 0 if we drank all of it. So we'd say 0 is equal to minus 5x plus 275. Subtract 275 from both sides. And we get negative 275 is equal to 5 minus 5x. And divide by minus 5 on both sides, and we would get 55 is equal to x. So the total from start to finish is almost a minute, so 55 seconds. And that would be my interpretation of the question. So how long did it take him to drink all the slushie? If it said how long did it take him to drink the remaining amount of slushie, then I would say it's from the 13-second point onwards. But for all of it, I would say what's the total amount of time? So like from start to finish, how long was it? And this is, again, why you show your work and why maybe you might justify your answer. So you might say like 55 seconds to, or we might say from start to finish. so that, if someone like me is coming by and evaluating your work, I might be like, okay, I see what they did there. I see why they did this. It's an accurate answer based on their interpretation of the problem. We're good with it. So make sure you are showing that work and writing some justification if you feel like it's necessary. Okay, so we got a new question. You're an avid coin collector. You want to start keeping better track of your coin collection. After 15 days, you count and you have 155 coins. After 22 days, you have a total of 218 coins. If this ever ends up being you in real life, you need to check yourself a little bit that you're suddenly acquiring all of these coins as a collector and you have no idea how many it's going on. But let's definitely dive into this problem as if it were a problem. Okay, so there's 2 time periods given to us. We have 2 coordinates. We have a 15-day mark and a 22-day mark, and then we have 155 coins and 218 coins. So these are actually 2 coordinates. So after 15 days, there is 155 coins, and after 22 days, there are 218 coins. So we have 2 points given to us, neither of which are the slope or the y-intercept, and those are the 2 things we really need to know. So what we're going to do first is figure out slope like we did in the last problem. So remember, that's m equals y2 minus y1 over x2 minus x1. So my values are going to come from the equation. So I got x1, y1, x2, and y2. So that'll be 218 minus 155 all over 22 minus 15. So 218 minus 55 is 63, and then 22 minus 15 is 7. And 63 divided by 7 is 9. So our slope is 9. And remember, slope is a rate of change. This is 9 coins per day. So he's acquiring about 9 coins per day. So he's really buying these things up fast. Point slope form. So this is one of our equations. This is y minus y1, m times x minus x1. Now guys, if you do not know that yet, you need to take that one and the y equals mx plus b formula, and the slope one as well. So these 3 need to go into the memory bank. So flashcards, posters, testing yourself on it, you need to make sure you know those 3 because you're going to use them like this in a test, and they're not going to be provided to you in every scenario. All right, so we are going to sub into the point slope form for y1, slope, and x1. And it doesn't matter which of the coordinates you pick, you will get the same answer either way once we go to part B. For part A, it will vary depending on which one you pick. So I'm going to do 15 and 155. So y minus 155 equals 9 and x minus 15. So that's it, I'm done. Point slope form, done. Define your variables. So y equals coins, x equals days. All right, part B, converted to slope-intercept form. This is when you do your distributive property. So we have 9 times x and 9 times minus 15 on the right. So I'm going to have y minus 155 equals 9x minus 9 times 10 is 90, plus another 45 is 135. And it's going to be a negative. Now, all I need is slope-intercept form, which is y equals mx plus b. So I need y on its own. I'm going to add 155 to both sides. So y equals 9x and then plus 20. So we've got slope of 9, y-intercept of 20, and then that's it, you're done. So we've got it. What does the y-intercept represent? So what does that 20 represent? So 20 is the y-intercept. 20 represents, so think about y-intercept. Starting at 20, it's going up by 9 every day. This is when x is 0 or time is 0. So this must be our starting number of coins. Now that could be like, this is the number he started with, like when he started collecting, but it kind of just seems like he decided to start keeping better track of his collection. So it was the day he started kind of keeping track of it. So very quick, he was like adding 9 coins a day. So only a short time into doing this, he's like, I better start tracking this. And then part D, how many coins would you expect to have after 50 days? So we go back to our point slope form and we say, okay, if this were a function, it would look something like f of x equals 9x plus 20. So it would be a little different appearing. It doesn't matter whether you use function notation or linear in this case. But what we are doing is we are saying if x was 50, so if we were doing 50 days, what would I expect my collection balance to be? 9 times 50 is 450 plus 20 is 470. So we would expect to have 470 coins after 50 days. Okay, so we got the second one. This is going to be your turn, so you're going to try this one out. Zookeeper thinks there's a problem with the naked mole rat population at the zoo, starts keeping track of the animals in the tunnels. 7 days into his monitoring, he counts 120 mole rats. 13 days in, he counts 108. So it's just like the last one. You've got two different points in time and their values that go with it. So x being time, y being the naked mole rat population number. Pause the video, try it out, come back and see how you did. Okay, so we need to figure out slope again. So that's our first stop. We've got day 7, 120 mole rats. Day 13, 108 of these mole rats. So I've got 108 minus 120 over 13 minus 7. And that's negative 12 over 6, which is negative 2 over 1, or negative 2. So we're losing 2 naked mole rats a day to whatever is causing this decrease in population, whether they're escaping or dying or getting eaten or whatever it is. Equation point slope form. So this is y minus y1. I'm going to use the 7 and 120 for this one. Minus 2, x minus 7. So just remember, if I chose the other point, it would look like this. Y minus 108 equals minus 2 times x minus 13. Both answers are correct in this scenario. So what happens is when we distribute and try and do part B, you will then get the same answer. But for part A, there's going to be 2 possible answers. Define variables, x equals days and y equals population. Where I'm going with that, population. All right, second part, convert into slope-intercept form. So we are going to distribute. So minus 2 times x minus 2 times 13. So y minus 108 equals minus 2x. Minus 2 times minus 13 is plus 26. And then we're going to get y in its own, so we're going to add 108 to both sides. We're going to get y equals minus 2x. 126 plus 108 is 134. What does the slope represent in this case? So minus 2 is the slope. So it means we are losing 2 mole rats, and then that's per day. So make sure you have the rate in there, so mole rats per day. If nothing changes, how many days will go by before the mole rats are all gone? So thinking of this again as an equation or a function, if the mole rats are all gone, that means the population is 0. So minus 2x plus 134. So we subtract 134 from both sides to get x on its own. And we divide by minus 2. And we would get 67 is equal to x. So 67 days before the population's gone. How many mole rats were there when he started monitoring? So started monitoring would be day 0. So we're looking for the y-intercept, which we already found. So we don't have to like go put in x is 0. It's just 134. 134 mole rats to start. Okay, so for tonight we have some Khan Academies. Check in your Khan Academy account. you'll be able to see all the ones that are available to you. We'll be practicing lots of what we did today, plus a little bit more. So a lot of kind of slope stuff from tables, from graphs, from word problems, that sort of thing. Essential questions: how do I find the slope and y-intercept when given a linear equation word problem? We find either if that information is given directly to us in the question, so they might tell us the rate of change and maybe another point, or they might tell us the rate of change and the y-intercept, or they might give us the y-intercept and another point. So sometimes they give us at least one of those pieces of information. Other times they don't. So like the last two problems we did, they just gave us 2 points that were not the intercept or the slope. We had to use slope formula first to find the slope. Then we put it in point slope form. So that's the y minus y1 equals m times x minus x1. And then we distributed and rewrote it in the form y equals mx plus b, which is called slope-intercept form. And that's where we can directly see the slope and the y-intercept in the equation. All right, for tonight, you got some Khan Academies to do. Thanks for stopping by. I'll see you soon.